Hello, thank you for the introduction. My name is Bartosz Trybus, and as you can see, there is a bunch of co-authors of this paper. I hope that some of my colleagues are now with us online. You have seen them briefly in the upper window for a moment. The team, since a few years, is working on RFID applications, especially those which involve a moving object like a robot or a vehicle, which communicates with RFID transponders. The transponders are often called identifiers or tags. Since this is the first time you are presenting the results during the FETSIS conference, I will start by presenting general concepts of the solution, and then I will go to the results. So let's consider an indoor space, like a room or a production hall, and the floor, as well as walls of the room, is covered with the transponders. The transponders create a grid, like you may see here. And also some equipment in the room may be also covered with the transponders. A mobile robot moves across the space and communicates with the transponders by reading their data or writing to their memory. If we consider such setup, we may find different applications. The first one is, of course, navigation. If we have some location or navigation data pre-programmed stored in the transponders, the robot may use this data to navigate, to reach its destination. But here we are saying about mapping. Mapping, in our terms, means exploring the area, the space. The robot explores the space and uses information already stored in the transponders. And in some of the solutions, we have special transponders called active transponders, which may present additional data by using the built-in sensors. For example, they may provide temperature or humidity. But here we focus on so-called passive transponders, and I will briefly explain how the system works. As I said earlier, the robot may read the data or store the data into the memory of the transponder. In order to achieve this, it must be equipped with a device which we call a reader-writer device or read-write device. The communication is wireless because it is radio-based, and to achieve this, the device is equipped with an antenna as well as the transponder. By using electromagnetic field, the transponder is powered to the level at which it is able to provide data to the device. And of course, the success of this communication depends on different factors. We say here about so-called interrogation zone, which may be also called zone of the correct work of the system. And as you may expect, it depends on several factors like distance, the strength of the magnetic field, the orientation of the antennas. So if we are thinking about exploring or mapping the surface, we may expect that the robot will step by step move from one of the transponder to the other and then orientate itself to achieve the best results. But of course, it will take time. So we are thinking about making the process more efficient. Our research focus on the two areas. One is related to the reader-writer device, and the other is related to the structure of the grid. I will now explain both of them. Let's start with the robot. And in our research, we made a robot prototype, which, as you may see, contains 4 reader-writer devices. By using 4 of them, we benefit in 2 ways. The first one is, of course, we can communicate with multiple transponders at a time. And of course, the other benefit is we don't need the robot to turn to make a large angle by turning itself so that the antennas will be in the proper orientation. Apart from the benefits, there are drawbacks of such setup. The problem we faced during using 4 reader-writer devices was, apart from the mechanical problems, was related to the software, because we have to manage 4 communication tracks at the same time. So we have to deal with some multitasking programming, which is, of course, always a challenge in case of microcontrollers like the one we use. The other aspect that we are researching is related to the structure of the transponders. They create a grid, and the pattern that the grid forms may be different. For example, here we see 2 patterns, 2 types of grids: the triangle one, which is this one, and the square one. The question is which one is better, and what factors should we take into account by analyzing the patterns. To have a better idea which one of the grid is better, computer simulation has been prepared using MATLAB software, which allows us to get such information like how many transponders is within the reach of the robot. We may compare the 2 types of grids, the triangle one and the square one. Please ignore the density of the transponders for now. The areas are the same. It is 0.45 meters, and the robot moves in different directions, but its path is straight. So we can see here route number 1, number 2, and number 3. In our research, we decided to select those tracks that always gives at least one transponder in the reach of the robot. And from the simulation, we can achieve the results. I present here just one result for route number 3 in the paper. It is presented in a slightly different way. But as you may see, the square grid turns out better in terms of reaching the larger number of transponders. The density then may be better, and as the result, we have more information that we can get or put into the transponders. So in terms of efficiency, this is very important. And as a summary, I would like to say that an experiment has been made with the robot prototype with 4 devices, 4 reader-writer devices, which gives us an improvement in terms of efficiency. And computer simulation has been carried out to determine which type of the grid is better. And as I said, the higher resolution of transponders gives us more information when we say, when we think about map. Okay, thank you very much.
Thank you very much for the very interesting presentation. Now we can start the discussion. Is there a question?
I'm curious about the factor between the distance between the grid points and the distance between the RFID sensors in the robot itself. Is there any connection between these two?
Yeah, there is a connection. Perhaps my colleagues will explain this better, but the simulation we are doing allows us to manipulate these parameters in freely. So we can get these results for different distances and different types of grids. As I said, I present here just a small fraction of the results. So don't focus on this single one.
Thank you. I have one about the triangulation. So why don't you use, for example, on 3 transponders and try to triangulate the position and depends on the position, send the different data?
I think you're saying about navigation, yes?
For example, but depending on the position, you can read from the triangulation, you can, for example, send a different data.
Yes, but note that we are not only focusing on the processing the data which we get from the transponders. We would like to have an efficient system in which the robots, by moving, is able to communicate with as much of the transponders as possible. So this is our goal. And the triangulation is one of the concepts that may be used to see if it improves or if it enlarges the number of transponders that we are able to reach. It may also be seen as beneficial because, as you may see here, the circles with the radius r are the same in this picture, and the areas that are not covered are seemingly smaller in the triangle grid. So we were thinking if the triangle grid would be better, but there are other factors which show that the square one is also acceptable, and in some when we certain conditions or certain assumptions, it may be chosen as the best.
Okay, thank you very much.